So now let us come to Stokes' law and the terminal velocity achieved by a spherical body. So Stokes showed that when a spherical body moves in a uniform fluid with a constant terminal velocity Vt, gets a resistance force given by 6 pi eta r Vt. So here eta is coefficient of viscosity, r is the radius of the sphere, and Vt is the terminal velocity. So the resistance force Vt is the velocity, we can call is the velocity, uniform velocity. It is the uniform velocity. Let us write it as V. So now when a spherical body is allowed to fall in a viscous medium, then the following forces act on it. Number one, its weight, that is W, denoted by W, that is 4 by 3 pi r cube. Its density is rho. Let its density be sigma and g. Second force acting will be buoyant force due to the liquid, that is given by 4 by 3 pi r cube rho g. This rho is for liquid. And the third force is its viscous drag, that is the resistance force F drag, that is minus 6 pi eta r V. So you see here, if we have a spherical object of radius r, then its weight is acting W. If it is coming down with velocity, then there is a buoyant force beta, and since velocity is here, there is a F drag force given by Stokes' law. For a spherical body, this is 6 pi eta r V. Now what happens? So due to these downward forces W, so initially when the speed is less, the downward force dominates, and thus the ball accelerates down. But soon it picks up speed, and so the drag force also increases. So now you see, as the velocity goes on increasing, the drag force increases. Soon the body acquires a special velocity called terminal velocity for which the net force is 0. So, you see, so is net force is 0. The body then moves with constant velocity, which is called terminal velocity. So, the net force becomes 0, that means weight, that is 4 by 3 pi r cube sigma g is balanced by buoyancy 4 by 3 pi r cube rho g plus 6 pi eta r v. So, it is terminal velocity. We will bring this 4 by 3 pi r cube rho sigma minus rho g, that is 6 pi eta r v t. So, you see the terminal velocity v t will be then this pi cancels. So, it will be this 2 will be there, 3 will be there. So, 2 r square sigma minus rho g by 9 eta. So, this is the terminal velocity for a spherical body which is falling under a liquid.